only did the fire itself pose a major threat to life and property, the burned mountainsides now pose a greatly increased risk of mudslides and flooding in the rainy winter months. We're especially concerned with those areas where mudslide and flooding could lead to a loss of life or property and lead to evacuations, like this area just north of Pasadena. What we want to do is plan for evacuations in the potential mudslide areas. We know where the populations are that will need to evacuate, and we have 36 potential locations for evacuation centers. What we want to do is choose the best locations for our evacuation centers so that we can minimize the travel time for all of our evacuees. In order to do this, we're going to use a new tool called location allocation. Our location allocation analysis takes as inputs those evacuating populations and our 36 potential locations for evacuation centers. I'm going to set some of the parameters for our analysis. For the problem type, we'll choose minimize impedance. This lets us minimize the travel time for all of the evacuees. We also want to choose 5 facilities. That means that out of those 36 potential locations, we're going to choose the 5 evacuation centers that will minimize the travel time for everyone. So I can accept those parameters and run the analysis. The results are going to be the 5 best locations for our evacuation centers. We can also use location allocation and other enhancements to network analysis to help us include some real-world challenges that we'll face in the event of a situation such as a mudslide. In this example, we've gotten word that there's some flooding that's going to be slowing down the evacuees as they make their way to safety in the event of an evacuation. In order to include that information in our analysis, we're going to rerun our location allocation analysis, this time with some barriers. So in order to include those flooded areas, all I have to do is draw some polygons on my map.